My name is Enji Alabadi, and this is Lab 2, Motion of a Fallen Object. I chose a basketball and went about the following task of analyzing the non-constant motion of an object and comparing it to two computational models with and without drag. In order to accomplish this, I first recorded a video of a basketball falling and then inputted this clip into Tracker. Tracker interpreted the data. Then I recreated this in GlowScript with and without drag as a factor. Some of the principles used were Newton's second law and the momentum principle. This was possible because the force was non-constant and the ball was falling with an acceleration equal to that of Earth's gravity. The programs used were Tracker, GlowScript, and Excel. This is the video of my lab and data that will be used. In the video, you can see the basketball falling to the ground. It has an initial velocity of 0 as it hits the floor. Then I inputted my video into Tracker. I used the diameter of the ball to get my scale and then marked the position of the ball every 0.1 seconds as my frame to get the position. When I recreated this in GlowScript without drag, I made the proportionality constant 0. Then I changed the time span, ball position, and ball velocity equations in order to make sure that it was taking into account that the forces were non-constant. Then I redid the code and took drag into account. I made my proportionality constant negative 0.03 to allow it to have the best and most accurate final position compared to the tracker data. Then I made a graph using Excel in which I compared all three cases, which were predicted with tracker, observed with GlowScript without drag, and GlowScript with drag. The observed position is the pink line. The predicted position without drag is the purple line, and the blue line is the data with drag. As you can see, when you take drag into account, the final positions are far more accurate, and the general trajectory is far more accurate compared to the predicted position without inputting drag as a factor. To answer question 1 about terminal velocity, my ball did not reach terminal velocity. Looking at the force diagram that was generated with GlowScript, the drag force pointing upward is far less than the force of gravity pointing downwards. As you can see in the chart above, as long as the two forces are different magnitudes, you will be experiencing some sort of acceleration rather than a terminal velocity. The second question was a scenario of the ball being thrown and not dropped from rest. The only difference in this case is that the terminal velocity would just be reached faster, not that the value itself would change. Overall drag can alter the computational model for objects being dropped, such as the basketball used. Thank you.